Do you know how a metal detector works?
A metal detector is an electronic device used to detect a metal nearby. It comprises of an oscillator which generates an AC current that passes by a coil, generating an alternating magnetic field. When a part of the metal is nearby to the coil, eddy current will be induced in the metal object and generates a magnetic field of its own.
The magnetic field cuts through the receiver coil, moving about up above it. The magnetic field makes electricity flow around the receiver coil and up into the receiver circuit at the top, making a loudspeaker buzz and alerting you.
Metal detector consists of a loop. Inside the metal detector's loop, there is a coil of wire called the transmit coil. Electronic current is driven through the coil to create an electromagnetic field. The direction of the current flow is reversed several thousand times every second. The transmit frequency refers to the number of times per second that the current flow goes from clockwise to counterclockwise and back to clockwise again. When the current flows in a given direction, a magnetic field is produced whose polarity points into the ground. When the current flow is reversed, the field's polarity points out of the ground. Any metallic object which happens to be nearby will have a flow of current induced inside of it by the influence of the changing magnetic field. In much the same way that an electric generator produces electricity by moving a coil of wire inside a fixed magnetic field. This current flow inside a metal object in turn produces its own magnetic field with a polarity that tends to be pointed opposite to the transmit field.
A second coil of wire inside the loop of the metal detector, the receive coil, is arranged so that nearly all of the current that would ordinarily flow in it due to the influence of the transmitted field is cancelled out. Therefore, the field produced by the currents flowing in the nearby metal object will cause currents to flow in the receive coil, which may be amplified and processed by the detector's electronics without being swamped by current resulting from the much stronger transmitted field. The resulting received signal will usually appear delayed when compared to the transmitted signal.